Hello there, and glad to have you aboard for another AirSim3D C560XL tutorial. So first off, as you can see, the aircraft kind of looks abnormal, looks off balance. Yeah, when flying it, it can be trimmed out, but this is not really normal, and the passengers will get all upset if you have to fly all wonky like this for the full duration of the flight. And while the co-pilot will be able to keep up and keep it on its course with lots of trim input, this is not a well-balanced aircraft, and imbalance can lead to all sorts of problems. So, how do we fix this? And more importantly, what could possibly cause this? Well, that's what we're here to discuss in today's tutorials. It's all about weights and balancing out the aircraft. Being unbalanced is not a recommended state for this aircraft, or any aircraft, or for other humans, or for pets, or for the global weather for that matter. But at least we can fix being imbalanced in this aircraft, so let's get right down to it. But to begin, we need to first say that the aircraft does not come with any fancy extra fuel and weight pop-out menus that essentially duplicates SIM functionality. We saw no reason to replicate that needlessly, but instead thought it would be wiser to save the FPS and apply those savings for more important things like failing every single major system realistically, as an example. We hope that you will agree that saving FPS at every opportunity is a good strategy to have had, as every little bit of saving contributes to help towards smoother overall flight experiences for you, the customer. Therefore, a pilot in the C560XL would edit weights and change fuel by accessing the SIM's Flight and Edit Weight and Balances menu. Play around with this menu to add passengers to seats, put bags in the hold, and fill tanks with fuel to meet the needs of the duration of the flight that you have planned. But just be aware that adding passengers in different seats and only on one side as an example with different weights changes the aircraft's center of gravity, overall balance, and therefore as a result its flight characteristics. This is all realistically modeled, and of course adding fuel to one side will cause an imbalance too. We recommend just using this total internal fuel weight slider to ensure that both tanks get the same quantity of fuel. And a couple of points about the CG and reference speeds in this aircraft. First, as we have said often in this tour and tutorial series, the C560XL is not an airliner. So please don't expect to do the same CG related actions you are used to taking in an airliner in this jet, or to fly it like you would a heavy airliner. Let's consider the differences between the two. Airliners have hundreds of passengers, carry thousands of pounds of luggage, and burn tens of thousands of pounds of fuel over the course of their long flights. As a result, in those machines, obviously, we can expect their center of gravity, commonly referred to as the CG, to shift significantly over the course of those long flights, and so their reference speeds that are needed to generate the lift needed to fly those enormous loads off and back down onto the ground will differ at the beginning compared to when they are at the end of their flights. So, they are big, heavy, and take a lot of energy to get up and fly. On the other hand, the C560XL can have under 10 people on board with a couple of 100 pounds of luggage maximum. And it also has an approximately 5-to-1 power to weight ratio over airliners. So it's on the opposite end of the spectrum compared to airliners. It's light and fast. So what all this means in practical terms for our SIM model is that the C560XL CG does not change much during a flight, precisely because the conditions that make big CG changes do not exist in its design. And the lift required to fly it, when it's heavy versus it's lightly loaded, is not that much different. Simply because you can't really load it up the way airliners can be loaded to affect the CG in the way airliner CGs are affected. What does change, and something that you should be thoughtful about, is the power and the time the aircraft requires to get to the reference speeds that you see on the speed tape. And also that the rate of how quickly you can drop into dangerous angles of attack will become faster and higher. But to overcome that, you have that high power to weight advantage. So if your loadout is tail heavy, then to fly safely, A, you will need more trim to overcome the jet's tendency to pitch up. B, you will need more power to get the jet moving to fly the right speeds. And remember, the reference speeds don't have as wide a margin of difference compared to heavy airliners. If, however, you do wish to fly very precise reference speeds, which by the way will be within the barber poles of the speed tape, then refer to the chart in the POH, search for the term takeoff performance. Oh, by the way, speaking of speed tape barber poles, the real aircraft does not have these. We added them simply for easier simulation reference and convenience only at different flap settings. Okay, back in the cockpit and a couple of points to remember. Number one, obviously the heavier the combined weight of the aircraft, the heavier it will feel during landing or takeoffs, so fly the aircraft accordingly. Number two, there are no maximum landing weight permitted in this aircraft, so therefore the aircraft does not have any in-flight fuel dumping operations. Number three, there are roll and yaw trim dials on the main center console. Clicking their center or tapping them on the top will quickly center these dials. 4. There is also a single trim wheel on the pilot side, and it too can be centered by clicking its center. By the way, if you ever see a no takeoff annunciation when everything else in the cockpit seems to be positioned correctly for takeoff, check here to make sure that the trim is centered. So that's all about trimming for weight and balance that is not fuel related. Now, the more likely contributor to a weight imbalance during a flight, and one that can cause significant flight characteristic changes, is having different quantities of fuel in each of the aircraft's fuel tanks. But wait a minute, how could that happen if the aircraft was loaded with tanks correctly balanced when the flight first started? You've heard us how authentic this aircraft's systems are. Well, 100% fuel imbalance modeling and fuel transfer system management is no different over here. So let's examine that. In the C560XL, there are two systems that use fuel, which might cause fuel imbalances if not properly managed. The first, obviously, is normal engine operations, where both engines are running and synchronized. They can be synchronized easily by clicking the region between the throttle handles, and when synchronized, they will use the same amount of fuel. Unless the jet uses asymmetrical power for some failure reason, or like it's being forced to fly on one engine mid-flight during an emergency. The second system that uses fuel is, you guessed it, when running the APU or the auxiliary power unit. Now, something critical to remember here. The C560XL's APU unit uses fuel from the starboard or right side tank only being the key and operative word over here. So, if you are running the APU for any length of time, even if it is with both engines running, expect that over time your right fuel quantity level will be lower when compared to the left or the port side. Now, a few gallons here or there difference doesn't really pose a problem, but if you have been running the APU on the ground before engine startup to power the avionics while you create a flight plan or while running through the checklists, then you will begin to see a fuel quantity imbalance between the tanks, and that will become very noticeable in the air. And how do we fix this? Well, if you're following the checklists, you are doing that as we have often recommended in all our tours and tutorials. Yes, you should be doing that. If you are following those checklists, then the taxi checklist specifically calls for a fuel imbalance check, as that needs to be equalized before takeoff, and we do this by using the jet's CrossFeed function. CrossFeed. What's that and how does it operate in the C560XL? Well, if you look down on the left side of the pilot side panel, notice this CrossFeed panel. How this works is that when you need to use fuel from the left side tank only, turn the dial so that its top points to the left or to the port side. Now, a couple of things will happen when you do this. First, the fuel boost pump switches just above it will turn on automatically if they are not already in that state. Having these on is needed for cross-feed procedures. Secondly, the right side fuel pump turns off. And lastly, the left side fuel pump stays on and therefore fuel will flow from the left tank only. Now looking at the labeling as Cessna designed it, and in this position the dial shows the feed to the right engine. And this can be a bit confusing, but be assured fuel is flowing to both engines and only being fed from the left tank. So separate the idea of using, which both engines are using fuel, from getting or sourcing fuel, and that's from the left tank only in this case. And how do we know all this is happening? Well, if you look at the fuel flow and quantity gauge on the upfront center dashboard, notice the fourth thing that is happening. That flow to both engines is normal and synchronized. However, fuel is being drawn down in the left tank only, as evidenced by the diminishing fuel quantity remaining numbers in the left tank column. The aircraft in this configuration is using fuel from the left side only. Now to use fuel from the right side only, you guessed it, move the top of the dial to the right. Obviously when the dial is centered, the aircraft is using fuel from both tanks equally, and this is the default configuration position. Now to remind you that the CrossFeed is on, notice the X feed and boost annunciator lights are now on. And that's the final thing. As with all systems in this aircraft, the upfront annunciator with its 90+ scenarios shows you when aircraft systems are functioning and running. So always pay attention to and assess what any of those lighted annunciations are telling you. Therefore, we see the X-feed annunciation lighted, it's commanding your attention, and so therefore remember to turn the CrossFeed off once you have achieved fuel quantity balance by centering the dial. So there you have it. Now the aircraft will fly nice and level in a balanced state. Looking good, feeling good. And until the next time, happy and balanced flying. Bye.